Today we shall learn about another named reactions in organic chemistry, that is Markovnikov rule and Anti-Markovnikov rules. These two rules are applicable when hydrogen halides HCl, HBr or HI are added to unsymmetrical alkenes. What are unsymmetrical alkenes? These are alkenes with two dissimilar groups attached to them. That is, dissimilar groups are attached to double bond. Let's see the example. Let's take propene. Propene is CH3CH double bond CH2. This is the double bond. So, to the double bond, one side is CH3CH, another side is CH2. So, these are the two dissimilar groups, that is CH3CH and CH2 are attached to the double bond. So, this is unsymmetrical alkene. Let's see another example. Pent1-ene. Pent1-ene is CH3, CH2, CH2, CH double bond CH2. So, the two dissimilar groups are this one and this one. That is CH3, CH2, CH2, CH is one group on this side of the double bond, and CH2 is the other group on this side of the double bond. So these are two dissimilar groups. They are attached to double bond. Another one is pent2-ene. So pent2-ene is CH3, CH2, CH double bond CH, CH3. This is one group, that is CH3, CH2, CH on this side of the double bond, CH, CH3 on that side of the double bond. These are the two dissimilar groups attached to the double bond. So this is also an unsymmetrical alkane. Now let's see what are symmetrical alkenes. Symmetrical alkenes are similar groups attached to the double bond. Example, ethene, CH2 double bond CH2. This is the double bond between these two carbon atoms. One side is CH2, another side is CH2. So, two similar groups, CH2, CH2 are attached to the double bond. But2-ene, but2-ene is CH3, CH double bond CH, CH3. This is the double bond. On either side of the double bond, we have CH3CH, CH3CH. So, these are two similar groups attached to the double bond. Let's see what happens when HBr is added to symmetrical alkenes. When symmetrical alkene like ethene is taken, CH2, CH2, and HBr is added to it, this hydrogen can go to this carbon atom and form bromoethene like this. Hydrogen here, bromine here, bromoethene. Or this hydrogen atom can go here and Br can go here. Still we'll get bromoethene only. There is no change. So that will become bromoethene only. Similarly, but2-ene. This is also symmetrical alkene because two similar groups are attached on either side of the double bond. And when we add HBr, we get bromobutane. Either the hydrogen can get attached to this carbon atom and then bromine attaches here. So bromobutane is formed. Or if the hydrogen gets attached here, bromine gets attached here. Either way it will be bromobutane only. There is no change. So when symmetrical alkenes are treated with HBr, we get only one product. But this is not the case with unsymmetrical alkenes. Let's see what happens when HBr is added to unsymmetrical alkenes. We get two products, a major product and a minor product. Let's see. CH3CH double bond CH2 reacts with HBr. So this is propene. We can either get CH3 CHBr CH2, that is CH3. That means bromine is getting attached here and hydrogen is getting attached here. This is 2-bromopropane because bromine is on the second carbon atom from this side or this side. So this is 2-bromopropane, or it can take place in opposite direction, that is bromine getting attached to the first carbon atom, last carbon atom, hydrogen getting attached in the middle. So we get 1-bromopropane. So we get two products when HBr is added to unsymmetrical alkene. So when no reagent is added to propene and HBr, 2-bromopropane, this is 2-bromopropane, is formed as the major product. This is according to Markovnikov rule. This is 2-bromopropane is the major product according to Markovnikov rule. It is an electrophilic addition reaction. So Markovnikov rule is an electrophilic addition reaction. When a peroxide or benzoyl peroxide is added to propene and HBr, we get 1-bromopropane as the major product. This is Anti-Markovnikov rule. It is a free radical addition reaction. Remember, Markovnikov rule is an electrophilic addition reaction. Anti-Markovnikov rule is free radical addition reaction. Now let's study one by one. Let's see Markovnikov rule. Markovnikov rule states that when an unsymmetrical alkene is treated with hydrogen halide, that is HCl, HBr or HI, without any other reagent, this is very important, without any other reagent, the negative part of the hydrogen halide gets attached to double bonded carbon atom with less number of hydrogen atoms. So the negative part of HBr would be Br minus. In this reaction, HBr becomes H plus and Br minus. How does it happen? In HBr, the bond is formed between hydrogen and bromine with 2 electrons. Bromine takes both the electrons and becomes Br minus because bromine is more electronegative. So it will take both electrons and form Br minus. So the left out hydrogen will become H plus. So this Br minus gets attached to that double bonded carbon atom which has less number of hydrogen atoms. So in propene, CH3CH double bond CH2, this is the double bond. These are the two double bonded carbon atoms. Of this CH or the second carbon atom is having less number of hydrogen atoms. So bromine gets, Br minus gets attached here. As a result, we get bromine gets attached here, hydrogen gets, H plus gets attached here. Br minus gets attached to the second carbon atom with less number of hydrogen atoms. Hydrogen gets attached to the last carbon atom, CH2. So we get CH3, CHBr, CH3. This is 2 and 1. So this is nothing but 2-bromopropane. This is the major product. So when unsymmetrical alkene is treated with hydrogen halide, we get 2-bromopropane or 2-bromoiodide or 2-bromochloride as major products. Let's see the mechanism. HBr undergoes ionization and splits as H plus and Br minus. We have already learned that. Br takes both the electrons of the bond between hydrogen and bromine and becomes Br minus. So this Br takes both the electrons and becomes Br minus. Hydrogen becomes H plus ion. Since hydrogen atom loses its electron, it becomes H plus. H plus is nothing but an electrophile. This electrophile initiates the reaction. So, Markovnikov rule, the electrophile initiates the reaction. HBr splits as H plus and Br minus. The electrophile H plus attacks the double bond of the alkene to form two carbocations. Let us see how it happens. CH3CH double bond CH2 plus HBr splits as H plus and Br minus. This H plus is attracted towards the double bond because it is an electrophile. The electrons are available in this double bond because one bond is sigma bond, another bond is pi bond. Pi bond is a rich source of electrons. So it attracts H plus ion. The H plus ion can get attached here to this carbon atom or to this carbon atom. If it is gets attached to this carbon atom, we get here CH2 instead, CH3, CH2, CH2. That means this pi bond breaks and forms a bond between second carbon atom and hydrogen ion. So this becomes CH2 and this carbon atom, since it loses an electron, it develops a positive charge. This is a carbocation. This is primary carbocation. This is less stable primary carbocation. If the hydrogen gets attached to the last carbon, that is third carbon atom, this bond breaks and forms the bond between hydrogen and carbon. So this carbon develops a positive charge and becomes secondary carbocation. This is more stable than the primary carbocation. Let's see how this happens. As I have already explained, when H plus, that is electrophile, attacks the double bond, which is a rich source of loosely held pi electrons, the pi bond breaks and forms a bond between H plus and carbon atom. This is how it happens. When this is the pi bond, this is sigma bond. This pi bond is having loosely held electrons. This pi bond breaks and forms a bond between hydrogen and this carbon atom. So we get CH3, CH, H and CH2. So since this carbon atom has lost its electron because the bond shifted here, it develops a positive charge and becomes primary carbocation. Since the pi electrons form a bond between second carbon and hydrogen ion, the third carbon develops a positive charge and becomes carbocation, that is primary carbocation, because only one carbon atom is attached to this carbon atom, so it is primary carbocation. This is less stable. Similarly, if the electrophile, that is H plus, attacks third carbon atom, this is the third carbon atom, then the pi electrons form a bond between third carbon atom and hydrogen ion, that is H plus. So the second carbon atom develops a positive charge and becomes a carbocation, that is secondary carbocation. I hope you understood this point. This is the second carbocation because the positive charge is on the second carbon atom. This carbon atom is attached to two other carbon atoms, so it is called secondary carbocation. This secondary carbocation is more stable. Now, these carbocations that are formed are attacked by Br minus to form major and minor products. When Br minus attacks the less stable primary carbocation, minor product, 1-bromopropane is formed. This is the primary carbocation. CH3, CH2, CH2 plus. So the bromine gets attached here and we get 1-bromopropane. This is minor product. When Br attacks the more stable secondary carbocation, we get major product. This is the secondary carbocation. CH3, CH plus charge on the second carbon atom and CH3 here. This is secondary carbocation because two carbon atoms are attached to this carbon atom. Br attacks this carbocation and becomes 2-bromopropane. This is the major product. This is Markovnikov rule. Now let us see Anti-Markovnikov rule. Anti-Markovnikov rule is also called peroxide effect because peroxide is added. It is Karash effect. It is also called Karash effect. So addition of HBr to unsymmetrical alkenes in presence of peroxide takes place against Markovnikov rule. So it is called Anti-Markovnikov rule. That is, here the minor product of Markovnikov rule becomes the major product. That is, 1-bromopropane becomes major product here. The minor product of Markovnikov rule becomes major product in presence of peroxide. This is Anti-Markovnikov rule. And the major product will become minor product. Minor becomes major here, major becomes minor here. Let's see how. This is the propene. CH3, CH double bond CH2. When HBr is added, in presence of peroxide, usually we take benzoyl peroxide, that is C6H5CO taken twice O2. It is benzoyl peroxide. We get 1-bromopropane as major product. That is, the bromine gets attached to the carbon with more number of hydrogen atoms, that is third carbon. Let's see the mechanism. This mechanism is free radical chain reaction or free radical addition reaction. That was electrophilic addition reaction. This is free radical addition reaction. So first the peroxide, that is benzoyl peroxide, undergoes homolytic cleavage of the bond between oxygen and oxygen to form free radicals. C6H5 C double bond O C double bond O C6H5. This is benzoyl peroxide. This bond between this oxygen atom and this oxygen atom undergoes homolytic cleavage. Homolytic cleavage means each atom will take one electron each from the bond. So as a result of which we get C6H5 C double bond O radical and another C6H5 C double bond O radical. So we get two free radicals here, C6H5 C double bond O radical and C6H5 C double bond O radical. So two such radicals are formed. Now, what is a free radical? Free radical is a species with unpaired electrons. So this oxygen has one unpaired electron. So it is a free radical. The two free radicals will undergo homolytic cleavage of C6H5 C double bond O bond to form two free radicals each. So C6H5 CO O radical. This bond between C6H5 cleaves and we get C6H5 radical, C radical O and O radical. And similarly here also this radical also splits C6H5 radical, C radical O radical. This radical and this radical will form a bond because this denotes an electron, this denotes an electron. So a bond is formed, as a result of which we get carbon dioxide. Here also we get carbon dioxide. So we are left with C6H5 radical and C6H5 radicals. Now, this C6H5 radical attacks HBr and causes homolytic cleavage of the bond between hydrogen and bromine. So this is how it happens. C6H5 radical attacks HBr. So the bond between hydrogen and bromine undergoes homolytic cleavage. We get H radical and Br radical. This is C6H5 radical. This C6H5 radical will form a bond with this hydrogen radical and forms C6H6. This is benzene and bromine free radical is there. Now in the next step, this bromine free radical attacks double bond of unsymmetrical alkene, that is propene. So only in the fourth step the unsymmetrical alkene is attacked. As a result, propene undergoes homolytic cleavage of pi bond to form free radicals. This bromine radical attacks the double bond of propene. Propene is CH3CH double bond CH2. So this bromine free radical attacks this double bond, as a result of which this CH takes one electron, this CH takes another electron. That is called homolytic cleavage. So we get CH3 CH radical and CH2 radical. These are also free radicals. Now the bromine can get attached to this free radical or this free radical. if it gets attached to this free radical, here the bromine is attached, CH3 CHBr CH2 free radical. This is less stable primary free radical because the radical is present on the first carbon atom or the carbon atom which is attached to a single carbon atom. So this is primary free radical. If bromine gets attached to this carbon atom, we get CH3 CH radical CH2Br. This is more stable secondary free radical because this carbon atom is attached to two other carbon atoms. So this is more stable secondary free radical. These free radicals attack HBr. So HBr undergoes homolytic cleavage to form H free radical and Br free radical. So this, let us take this primary free radical CH3 CHBr CH2 radical. This is primary free radical attacks HBr. So we get H radical and Br radical. Now the hydrogen radical will get attached to this primary free radical. So we get minor product because primary radical is less stable. So we get CH3 CHBr CH3. This is less stable. This radical is less stable, so we get minor product here. This is 2-bromo-propane, and this bromine radical remains like this. So 2-bromo-propane is minor product. Let's see what happens when bromine free radical attacks secondary free radical. So this is secondary free radical. Bromine got attached here to the first carbon. So this is the secondary free radical. So this attacks HBr. As a result, the bond between hydrogen and bromine undergoes homolytic cleavage, as a result of which we get H radical and bromine radical. This hydrogen radical will get attached to this carbon atom, that is secondary free radical. So we get 1-bromo-propane as major product, CH3 CH2 CH2Br. This is 1-bromo-propane. This bromine free radical remains. Now in the last step, two bromine radicals will combine with each other to form bromine molecule. Bromine radical plus bromine radical will combine to form a bond between them, which is bromine molecule or bromide molecule. Let's see the note. The note says peroxide effect is seen only with HBr. It is not seen with HCl and HI. It is not seen with HCl because the bond between hydrogen and chlorine is stronger than HBr bond. So HCl bond cannot be broken by free radicals formed by peroxide. So the free radicals cannot break the bond between hydrogen and chlorine. It is not seen with HI also. Though HI bond is weaker than HBr, it is not formed because the HI bond is cleaved by free radicals. But iodine free radicals formed do not attack the double bond of the alkene. Instead, the iodine free radicals combine to form iodine molecule. So this is how Hi does not give anti-Markovnikov product. Let's see the summary. In summary, Markovnikov rule: CH3CH double bond CH2 is propene. When it is added to HBr, HBr becomes H plus and Br minus. This H plus can attack this double bond and to give and gets attached here to this carbon atom or this carbon atom. When it gets attached to the second carbon atom here, we get CH3, CH2, CH2 plus. This is the less stable primary carbocation. If the hydrogen gets attached to this carbon atom, we get secondary carbocation, which is more stable. Now this secondary carbocation, which is more stable, is attacked by Br minus. So we get bromine attached to secondary carbocation. We get 2-bromopropane as major product. This is the less stable primary carbocation because plus sign or the positive charge is present on the first carbon atom. This is primary carbocation. When Br minus attacks this, we get bromine attached to this first carbon atom. So this is 1-bromopropane. This is minor product. So this is the mechanism of Markovnikov rule. Now let us see, in summary, the anti-Markovnikov rule or peroxide effect or Karash effect. CH3CH double bond CH2, that is propene, plus HBr in presence of peroxide, that is benzoyl peroxide. We get this as major product, 1-bromopropane, CH3CH2 CH2Br. This is 1-bromopropane. This is the major product. Now the mechanism, as already I have told, this is how it goes. First, the peroxide will undergo homolytic cleavage of oxygen-oxygen bond, as a result of which we get two free radicals, C6H5 C double bond O radical, two such radicals. Now then the bond between C6H5 and this C double bond O radical, this bond will undergo homolytic cleavage, as a result of which we get two C6H5 free radicals and 2 moles of carbon dioxide. This C double bond O and will combine to form CO2. So we get two such carbon dioxide molecules. Now this C6H5 free radical will attack the HBr. So the HBr bond undergoes homolytic cleavage and forms Br minus Br radical and H radical. H radical will combine with C6H5 free radical to form C6H5, C6H6, that is benzene. This bromine radical is there. Now this bromine radical will now attack the propene. So the bromine radical will attack the double bond of this unsymmetrical alkene. So if the bromine gets attached to this carbon atom, we get primary free radical. This is primary free radical, which is less stable. If the bromine gets attached to this carbon atom, we get more stable secondary free radical. Now, so let's see First, the less stable primary free radical. This is CH3 CH radical, CH2Br. This is primary free radical. This primary free radical attacks hydrogen bromide. As a result, hydrogen bromide splits into bromine radical and H radical. This H radical will get attached to the second carbon radical. So as a result, we get CH3, CH2, CH2Br. This is 1 bromopropane because bromine is added to first carbon atom. This is the major product. This is secondary carbocation. So this is more stable carbocation. This is secondary carbocation getting attached to hydrogen. So we get 1 bromopropane as major product. Let us see how minor product is formed. When the less stable primary free radical, that is CH3CHBr, CH2 radical, this is primary free radical, it attacks HBr. As a result, HBr bond breaks and becomes H radical and Br radical. This H radical gets attached to this carbon atom. So we get CH3 CHBr CH3. This is the minor product because it is formed from less stable primary free radical. So this is 2 bromopropane. This is minor product and bromine radical is left out. In the last step, 2 bromine free radicals will combine to form a bromine molecule. So this is Anti-Markovnikov Rule. So as told already, Markovnikov Rule is electrophilic addition reaction. It starts with electrophile formed from HBr, whereas Anti-Markovnikov Rule is free radical addition reaction. It starts with free radicals and it undergoes chain reactions, and here we get 1 bromopropane as major product, whereas in Markovnikov Rule we get 2 bromopropane as major product. In Markovnikov Rule we do not add any other reagent. In Anti-Markovnikov Rule we add peroxide. Peroxide is not a catalyst. It undergoes homolytic cleavage to form free radicals, so we cannot call it a catalyst. Please remember it. Thanks for watching. Please share, subscribe and like. Thanks.